we're going to look at the binomial theorem. Now, the binomial theorem can be done a couple different ways. I'm going to use the Pascal's triangle approach. Now, a binomial is just two terms added together. So if we had x plus y, which is a binomial, and it's all raised to the fifth power, you could go ahead and go x plus y, 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 and then you'd have to multiply that out. You'd FOIL the first two, get x squared plus 2xy plus y squared. Multiply that by your x plus y, get that answer, multiply it by another x plus y, get that answer, multiply it by your last x plus y. It can be done that way, but there's an easier way. You can also use the binomial theorem, which says you can use this big, ugly, scary looking formula. It'll work just fine. It's not what I prefer to do. I prefer to use Pascal's triangle. What you see here is the beginnings of Pascal's triangle, and it actually continues on forever. So you start with a 1, and you always have 1s going down your diagonal. And then you go 1, 1. Then you go 1, 2, 1. Well, where does the 2 come from? Well, it comes from taking the 1 here and the 1 here and adding them together. Once again, 1's going down the diagonal, so they're on the outside. Where does this 3 come from? From adding the 1 and the 2 together. This 3 comes from adding the 2 and the 1 together. So in other words, to get the numbers in the middle, you're adding the two numbers that are just above it on each side of it. So when we look at the next one, the 4 comes from the 1 and the 3. The 6 comes from the 3 and the 3. The 4 comes from the 3 and the 1. And we continue that. 1's down the outside. The 1 and the 5 here, or 1 and the 4 give us 5. The 4 and the 6 give us the 10. The 6 and the 4 give us 10. The 4 and the 5, or 4 and the 1 give us the 5, and so on. So Pascal's triangle continues on and on and on, and you can extend it to whatever level you need. Now, if we were looking at this right here, x plus y to the fifth, we would then want to use our fifth row going across. So let's go ahead and work that out. So let's take a look at expanding this right here. You'd want to identify the correct row, and that's given to you by your exponent. So if your exponent's 5, you want to go to the fifth row. The second number in always tells you which row you're dealing with. Then you want to write out the numbers of that row separated by space with plus signs in front of them. Then you want to take the first term, raise to your highest exponent of 5, and then you're going to decrease that by 1 as you go across. And then vice versa for the y. And then we might need to simplify. So we're going to write down the fifth row of Pascal's triangle. So I have 1 space with a plus 5 space, plus 10 space, plus 10 space, plus 5 space, plus 1. So now x is at the beginning. So I'm going to start at the very beginning and put x to the fifth power. Then for my next term, I'm going to put x, but I need to decrease my exponent by 1. And then I'm going to put x, decrease my exponent by 1. Put x, decrease my exponent by 1. Put x, decrease my exponent by 1. And then put x, decrease it by 1. Now, not everybody writes x to the 0, because x to the 0 is really 1, and multiplying by 1 doesn't change it. Then I look here, I have a green y at the end. So I need to go to the end over here, and I'm going to start with the same thing I was doing before. I'll go y to the fifth, and then I'll work backwards and go y to the fourth, decreasing it by 1 each time. And then y cubed, and y squared, and then y to the first, and then y to the 0, which is not needed, y to the 0, because y to the 0 is 1. All we're going to do is simplify. y to the 0 is 1 times my red 1 times my y to the 5th is y to the 5th. There's nothing more I can do to simplify here. Nothing I can do to simplify here. And same on, except for the last one. That one does simplify. Now, a lot of times when you're doing Pascal's triangle with the binomial theorem, it will end up having all these simplifying a lot more, but in this case it doesn't. By the way, if you needed to work out 12 factorial over 4 factorial, remember 12 factorial is 12 times 11 times 10 times 9 times 8, all the way down to 1 over 4 factorial is 4 times 3 times 2 times 1. Now, keep in mind that 4 over 4, that's going to cross out. 3 over 3, that's a special form of 1. Same thing with 2 over 2 and 1 over 1. So that's not going to be needed. So really, your final thing you need to work out is this here. Oops, writing through the numbers, that's not good. So you could also go ahead, oops, man, I'm making mistakes. Sorry about that. So we'll try that some more. Sorry about that. So we could actually just type this into our calculator. We could go ahead and go 12, hit math, arrow over to prob, hit number 4, which is your factorial, then hit divide, go 4, go back to math to get the factorial underneath prob. And that's another way we could go ahead and work that out versus doing it by hand. So let's take a look at this one here. Now the binomial theorem in Pascal's triangle really doesn't work with subtraction. But remember, subtraction is adding the opposite. So I'm going to go a plus a negative c. Our exponent's 7, so go to our 7th row and write those numbers down with plus signs and spaces. Then we go to the a. That's in the beginning. I'm going to put that in the beginning and use my highest exponent of 7. And then decrease my exponent on that a as I go across, decreasing it by 1 each and every time. Now keep in mind the last one would really be a to the 0, but a to the 0 is 1, so it's not needed to write. The negative red c is at the end, so I need to go to the end, and then I start the same pattern. Negative c to the 7th. You need to put the negative c to this in the parentheses so that the 7 applies to the negative and the c. And then decrease that exponent by 1 going across. Negative c to the 6th, negative c to the 5th, negative c to the 4th, negative c to the 3rd, negative c to the 2nd, negative c to the 1st. Then we want to go ahead and work this out. 1 times a to the 7th is just a to the 7th. Now, my negative c times my 7a to the 6th is really just a negative 7a times c. When I work this one out, a negative c squared, a negative squared is positive, so that does not change it. But now for the next one, I have a negative raised to an odd power, so that's going to be negative. And so I have this. And then I continue across, simplifying. Remembering that a negative to an even power is positive, while a negative to an odd power is negative. Well, consider this one here. Suppose you wanted only the 5th term of this whole thing right here. There's a couple ways you could do that, but we're going to do that in the next video.